There's a molecule inside a bird's eye that may be tapping into one of the spookiest effects in all of physics, just to find its way home. Imagine if your eyes could literally see the planet's magnetic field as a glowing compass painted over the world. For one tiny songbird, that bizarre superpower isn't science fiction. It's quantum mechanics, and scientists just proved it's real. Fact 1. The impossible journey. Every year, the European robin flies thousands of miles between breeding and wintering grounds, often at night with no visible landmarks. Somehow it finds its way with stunning precision. The secret isn't just the stars. It's an internal compass tuned to Earth itself. Fact 2. A sixth sense. Many migratory birds can detect Earth's magnetic field, an ability called magnetoreception. This invisible sense lets them know which direction is north without any external cues. For decades, scientists couldn't explain exactly how the body could pick up such a faint signal. Fact 3. It's in the eyes. The leading theory says the bird's compass lives in its eyes, not its beak. A special protein called cryptochrome reacts to incoming light, kicking off a chain of chemistry that responds to magnetic fields. In other words, the bird may literally see direction. Fact 4. Inner quantum weirdness. When light hits cryptochrome, it creates a pair of molecules, each carrying an unpaired electron, known as a radical pair. These two electrons become quantum-linked, their spins delicately connected. This is where Earth's magnetic field gets to play with quantum mechanics. Fact 5. Spooky entanglement. The linked electron spins exist in a fragile superposition, behaving in ways that depend on each other across space. Earth's magnetic field subtly nudges how these spins evolve, changing the chemical outcome of the reaction. That tiny tilt becomes information the bird's brain can read. Fact 6. The protein proof. In 2021, researchers extracted cryptochrome, 4 from robins, and tested it in the lab. They found it really is magnetically sensitive, reacting to applied magnetic fields, just as the theory predicted. Crucially, the robin's version was more sensitive than that of non-migratory birds like chickens and pigeons. Fact 7. Faint but powerful. Earth's magnetic field is incredibly weak, about 100 times weaker than a fridge magnet. Classical chemistry shouldn't be able to notice something that's subtle. Only quantum effects in a radical pair can amplify such a whisper into a usable signal. Fact 8. Light required. Because the process starts with light hitting cryptochrome, the bird's magnetic sense actually depends on illumination. Experiments show that the compass works under blue and green light, but breaks down under red light. Take away the right light, and the bird gets lost. Fact 9. Disrupted by noise. Researchers found that weak radio frequency fields, far too feeble to affect normal chemistry, can scramble a bird's sense of direction. That's a telltale fingerprint of a quantum process at work. It's strong evidence the radical pair mechanism is genuinely behind the magic. Fact 10. Why it matters. Quantum effects were long thought to be too fragile to survive in warm, messy, living tissue. If birds maintain quantum coherence long enough to navigate, biology is exploiting physics we barely understand. Scientists now hope these feather navigators could inspire new quantum sensors built by humans. Nature was running quantum experiments long before we ever built a lab. If your brain just lit up like a cryptochrome molecule, subscribe for daily videos and keep the curiosity flowing.